Hello, welcome back to another video. This video is going to be a brief introduction to combinations and permutations, and this is going to be a really basic introduction. It's just to have a short video for you to refer to in case you ever forget or need a refresher on what exactly these two are at their most fundamental level. So let's start with combination. So combination is a way in which we can group things and just group things, and order doesn't really matter. So they could be in any order, and for teams, committee members, letters, etc. So like if they asked you, if you had a question, for example, what I mean by these is that if you had a question about splitting people into teams, or talking about committee members, or arranging letters, order typically doesn't matter, and that means that you could have them in any order whatsoever. So the way you specifically separate these things, all that matters are like the units. So for example, if you have letters A, B, C, and D, and you want to see how many times you could arrange them, A, B, and BA are the same thing because order doesn't matter. All right. So you can write a combination as NCR, and you can honestly just plug this right into your calculator. Most calculators have a combination and permutation function already built into them, but how to write it out is n factorial over n minus r factorial times r factorial. And so n is the number of things that you have, and r is the number taken at a time. So let's go back to our ABCD example. So ABCD is A, B, C, D. So that's 4 letters. So n is 4. But let's say we wanted to organize them in see how many times we could organize them by 2 letters, then r would be 2. Okay. All right, so now let's go on to permutation. So for permutation, order does absolutely matter. So questions that are asking you things such as like ranking or places in a race, stuff like that, order will matter because you want to know how many different ways people can be ranked, or how many different ways you can like order something. So order definitely matters because AB is different from BA, whereas combination AB and BA are the exact same thing, and it should be counted as 1. But permutation, those would be counted as 2. And this you organize as NPR. Number of things stays the same, and number taken at a time stays. N and R are the same thing as they were with combination. And this algebra is a little bit different because it's n factorial over n minus r factorial. So combination has the extra r factorial that you multiply in the denominator. So let's move on to the first question. So how many different ways can 3 letters be chose from the letters A, B, C, D, and E? The order of letters is not important. So if the orders of letters is not important, then that means we're going with combination. So we have A, B, C, D, and E. This is 5 letters. Okay, so we have 5, choose, and how many different ways can 3 letters be chosen? So 5, choose 3, plug that into your calculator, that equals 10. So I'm going to show you just real quick how I would do that if I was using the kind of like formula kind of thing. So we have 5 factorial over n minus r factorial times r factorial. So that's 2 factorial times 3 factorial. So now what is this actually, right? We have 5 times 4 times 3 times 2 times 1 over 2 times 1 times 3 times 2 times 1. Okay. So this is basically saying 4 times 3, right? Because 2 times 3 times 2 is 12. So we have 5 times 4 times 3 times 2. I'm just going to leave out the 1 time over 12. 12 is what equals 12? Well, these two equal 12. So that means we can cancel these out and we're left with 10 on the numerator. So that's how you would just do that out like that. Okay, so let's move on to the next one. A standard poker hand consists of 5 cards dealt from a deck of 52. How many different poker hands are possible? After the cards are dealt, the player may reorder them, so order is not important. We're dealing with combinations again. So again, just standard combination. We have, so a standard 5 cards dealt from a deck of 52. So there are 52 cards in total, and we want to choose 5 cards. We want to order them 5 cards each. And that equals, if we just plug this into our calculator using the, so on the nSpire, you press menu, go into probability, and then type in, then press combinations, and you just type in 52, 5, and then you get 2,598,960. Okay, let's move on to the next one. You are forming a 12-member swim team from 10 girls and 15 boys. The team must consist of 5 girls and 7 boys. How many different 12-member teams are possible? All right. So this again is a combination, because what I say earlier, when you're talking about teams, it doesn't really matter, because it doesn't matter unless there are specific roles like president, secretary, treasurer. Order doesn't matter, because a team of ABC and a team of BCA are the same team. So this is a combination. So you're forming 12-member swim team. Okay, so 12-member from 10 girls and 15 boys. 5 girls and 7 boys. Okay, so how are we going to do this? We have 10 girls, so 10 choose 5, because we have to choose 5 girls, times 15 choose 5. Oh, 7. 7. Okay. When you have 2 different parts of a problem, you want to multiply them together, because that's how probability works, as I'm sure you've already learned. So what's 10 choose 5? Let's again let's go back into our calculator. Okay, so we have 10, 5. And then we have, so that equals 252. Combination, and then 15, 7, 6, 4, 3, 5. 252 times 6, 4, 3, 5 equals 1,621,620. 1,621,620. So that's how you do that kind of a little bit more complex combination problem. Now we're at our last problem of the day. Told you this was going to be short. I don't want to make 30-minute videos every time, because it's not very efficient for people that want to watch these videos as quick practice. Okay, so how many different batting orders can a baseball coach create from a team of 15 players if there are 9 positions to fill? Okay, so something very important to notice: how many different batting orders? Well, that screams to me that order matters, obviously, because how many different orders? It's basically saying how many orders can you create, and that we know is a permutation. So there are 15 players and 9 positions to fill. Simple enough. 15 permutation 9. And again, type that into your trusty calculator, and if not, you can just do it using the formula I provided. 15, 9. Wow, it's a big number. 181,621,4400. That is the answer. Okay, so I got this problem from the same book as last time, the same Precalculus book as last time. I'm pretty sure it's called Precalculus Without Limits or with limits. The link will, of course, be in the description below, as always. Yeah, so thank you for watching. Let me know if you have any questions or requests in the comments below, and have a great day.